Right now, 4 million suns are being crushed into a space smaller than our solar system. And it's sitting at the center of everything you've ever seen in the night sky. By the end of this video, you'll know exactly what's buried at the heart of the Milky Way, what it's doing to the stars around it, what it already devoured, and why the discovery that proved it exists nearly destroyed the careers of the scientists who found it. You've seen pictures of the Milky Way your entire life. That wide, glittering spiral, billions of stars woven into elegant arms, pinwheeling slowly through the cosmos. It looks peaceful. Almost gentle. But here's what those pretty pictures never show you. The Milky Way is not a calm place. It is a violent, ancient structure roughly 100,000 light-years across, and at its absolute center, there is a region so extreme, so warped, that the normal rules of physics begin to break down. We call that region the galactic center. And for most of human history, we had no idea it even existed. Think about that. We live inside this galaxy. We are one of its 400 billion stars. And yet the thing sitting at its very heart was completely invisible to us, not because it was small, but because the Milky Way itself was hiding it. Between Earth and the galactic center lies roughly 26,000 light-years of gas, dust, and dense star clouds. Optical telescopes, the kind that detect visible light, are completely useless here. The dust absorbs and scatters the light before it ever reaches us. Looking toward the center of our own galaxy with a regular telescope is like trying to see a bonfire through 100 miles of fog. So for centuries, astronomers pointed their telescopes everywhere but the center because there was simply nothing to see. Until we learned to listen in a different frequency. In the 1930s, a Bell Labs engineer named Carl Jansky was trying to track down interference in transatlantic radio signals. He built a rotating antenna in a New Jersey field, something his colleagues quietly called Jansky's merry-go-round, and he started cataloging sources of noise. Most of the interference made sense. Nearby thunderstorms. Distant thunderstorms. Static. But one source didn't. There was a persistent hiss coming from a fixed point in the sky. It moved, but it moved with the stars, not with the weather. Jansky tracked it for months. And when he finally pinpointed its origin, he found it was coming from the direction of the constellation Sagittarius. The direction of the galactic center. Jansky had accidentally discovered that the heart of our galaxy was broadcasting radio waves. Not metaphorically, literally transmitting energy outward, constantly, in every direction. That discovery launched an entirely new field, radio astronomy. And over the following decades, as our instruments grew more powerful, the picture at the center of the Milky Way started to come into focus. What they found was not calm. It was not orderly. Stars near the galactic center were moving at extraordinary speeds, thousands of kilometers per second, whipping around some invisible point. Gas clouds were being stretched and torn apart. There were regions of intense radiation, massive shock waves, and structures that had no business existing if the center was just empty space. Something was there. Something enormous. Something that wasn't releasing light. And that's when the real investigation began. Here's where the story gets genuinely extraordinary. In the 1990s, two competing teams of astronomers, one in Germany, one in California, pointed their best infrared telescopes at the galactic center and started doing something almost obsessively patient. They watched. Year after year. Mapping the positions of individual stars in one of the most densely packed, chaotic regions of the galaxy. Why infrared? Because infrared light punches through the dust that blocks visible light. For the first time, astronomers could actually see stars near the galactic center, and what they saw immediately raised every alarm in astrophysics. The stars were moving wrong. Not slowly drifting, the way most stars move relative to each other. These stars were screaming through space in tight, elliptical orbits, completing full loops around a single invisible point in just a few years. One star, designated S2, completes a full orbit in roughly 16 years. At its closest approach to that central point, it reaches speeds of nearly 3% the speed of light. 3% the speed of light. To put that in perspective, Voyager 1, the fastest human-made object we've ever launched, travels at roughly 0.006% the speed of light. S2 is going 500 times faster than that. And it's being swung around something we cannot see. The math was undeniable. Whatever was at the center, it had to contain the mass of approximately 4 million suns, compressed into a region smaller than the distance from the Earth to the Sun. But here's what they didn't tell you in the headlines. Proving this nearly ended careers. Because what the math was pointing to was something that many physicists, even in the 1990s, still believed might not actually exist outside of theoretical equations. A black hole. And before we get to what they actually found, what happened when they finally looked directly at it, you need to understand something even stranger. The black hole at the center of the Milky Way is not behaving the way it should. Its name is Sagittarius A star. Written SGRA. And it is our galaxy's central supermassive black hole. For decades, we knew it was there by inference, by the orbits of the stars around it, by the radio emissions, by the gravitational fingerprint it left on everything nearby. But we had never seen it. Not directly. Not even close. Then, in April 2022, everything changed. The Event Horizon Telescope, a planet-spanning network of synchronized radio observatories working together as one Earth-sized instrument, released the first-ever direct image of Sagittarius A. It was a blurry, glowing ring. Orange and gold and trembling with heat. A donut of light surrounding a perfect, consuming darkness. That darkness is the shadow of the event horizon. The point of no return. The edge beyond which not even light escapes. For the first time in human history, we were looking at the actual boundary of our galaxy's central black hole. But here is where Sagittarius A breaks the mold, and why scientists are still puzzling over it. Most galaxies of the Milky Way size host what are called active galactic nuclei. Their central black holes are feeding constantly, consuming gas and dust and stars at such a ferocious rate that they outshine entire galaxies. Quasars, blazars, the most luminous objects in the observable universe, all powered by actively feeding supermassive black holes. Sagittarius A is quiet. Eerily, suspiciously quiet. For its size, it is consuming almost nothing. It sits at the center of 400 billion stars, and barely eats. Astronomers describe it as being in a kind of dormant state, and the question that genuinely keeps some of them awake at night is this. Was it always this quiet? Or, did something change? Because here's what we found above and below the galaxy, and it changes everything. Extending roughly 25,000 light-years above and below the plane of the Milky Way are two colossal structures, invisible to the naked eye, invisible to optical telescopes, but blazing in gamma rays and X-rays when viewed with the right instruments. They are called the Fermi bubbles. Discovered in 2010 using NASA's Fermi Gamma Ray Space Telescope, these structures are each roughly as large as the galaxy itself is wide. They are expanding outward from the galactic center, right now. The leading explanation? Sagittarius A wasn't always sleeping. Somewhere between 1 and 4 million years ago, which on cosmic timescales is basically yesterday, our central black hole had a massive feeding event. It consumed an enormous amount of material, launched jets of energy and plasma outward at near light speed, and blasted these two enormous bubbles into the halo of the galaxy. Think about that. 1 to 4 million years ago, there were early hominids walking the African savanna. And above their heads, had they been able to see it, the galaxy was putting on the most violent light show in its recent history. The echoes of that eruption are still expanding outward today. Sagittarius A isn't just a relic or a gravitational curiosity. It is a sleeping giant with a documented history of violence. And the future? It is already written. Right now, a massive cloud of gas and a stream of stellar material is falling towards Sagittarius A. Astronomers are watching it in real time. When it arrives, and the timescales are uncertain, it could trigger a new feeding event. Even more dramatically, the Milky Way is on a collision course with our nearest large galactic neighbor, the Andromeda Galaxy. In approximately 4.5 billion years, these two galaxies will merge. The supermassive black holes at each of their centers, Sagittarius A and Andromeda's own giant, will spiral toward each other, sending gravitational waves rippling through spacetime, and eventually merge into something almost incomprehensibly massive. The center of what we call home will be transformed into one of the most energetic events the universe has ever produced. The sleeping giant will wake. So here is what is hiding at the center of the Milky Way. A black hole 4 million times more massive than our Sun. Caught in a rare moment of quiet, surrounded by stars moving at impossible speeds, scarred by ancient eruptions that are still expanding today, and waiting patiently for its next meal. We didn't know it existed a century ago. We couldn't photograph it until 2022. And we still don't fully understand why it's so still. The center of your galaxy is one of the most extreme environments in the known universe, and it is only 26,000 light-years away. If that broke your brain even a little, subscribe. We drop one of these every week. And next time, we're going even deeper. What would actually happen to you if you fell into a black hole? Not the Hollywood version. The real physics. And the answer is far stranger than you think.